All right, let's start off here on number 1. So we want the rule for the nth term. So it's really asking for the explicit formula here. So if I'm finding that, I would first want to find out what r is. So for r, I can do any number divided by the number in front of it. So I'll just do the first two here. And so that's going to, if I reduce that, or actually, I'm just going to use a decimal for this since it says around the answers. So if I type that in the calculator, it's just going to come out to negative 2.5. And then I know that a sub 1 is 8, and so I'm just going to use the a sub 1 version of my formula here, which will be 8 times negative 2.5 to the power of n minus 1. You could find out what a sub 0 is here. If I did 8 divided by negative 2.5, it's going to tell me negative 3.2. So another option for that would be negative 3.2 times negative 2.5 to the power of n. If you want to use the a sub 0 here, then that exponent changes to n. So then either way, we just want to figure out a sub 5 and a sub 8. So for a sub 5, I would just do 8 times negative 2.5 to actually the power of 7, because I'm just going to do that 8. Oh, wait, no, that's the next one. So this one would be the power of 4. Since I would do the 5 minus 1 kind of in my head there, I would just type that in the calculator. So 2 times negative 2.5 to the power of 4, and that's going to be 312.5. All right, next up here we got number 2. So that one's asking us once again to write the rule for the nth term. So remember our kind of technical definition for r is a2 over a1, or it's really any term in front of the divided by the term in front of it. So in this case, I'm going to say that's negative x over 6 over 1, and that's actually pretty easy to divide by 1. So r is just negative x over 6. And I know a1 is 1, and so I'm just going to say that this is a sub n equals 1 times negative x over 6 to the power of n minus 1, which I actually wouldn't have that multiplying 1 out front just because it's not necessary. So I'm going to write it like that. All right, so then for a sub 5, that would be negative x over 6 to the power of 4. And so I know on the numerator there, when it's an even power, that's going to make it positive x to the 4th power. And then on bottom, I'm just going to do 6 to the 4th power in the calculator. So that's 1296. So that's what I would get there, x to the 4th over 1296. So then for a sub 8, that's going to be negative x over 6 to the power of 7, because it's a n minus 1 power. So actually, since this is an odd power, that's going to stay negative x, but now it's going to be to the power of 7. And then in the calculator, I would do 6 to the 7th power, which is 279936. So that would just go right there. All right, next up here, we would come up with r that will get us from a sub 3 to a sub 6. So I think what I would do on this one, I would put a sub 3 right there, a sub 4, a sub 5, and a sub 6. And we know this one's 48, and we know this one's 6. So we need to think, what do I need to multiply by? And remember, that's got to be something that's multiplying here. So if I multiply it 3 times, it gets me over to 48. So I don't really know here, so I'm just going to try out 3 here and see if it works. So if I multiply by 3 every time, I get 18 here, and then 18 times 3 is 54, and so obviously that's not going to work out here, so 3 does not work. So first trial, no good, and I kind of get a little clue there that I need it to be actually smaller than 3. So I'm now going to try times 2. So when I do times 2, that turns into 12, and then times 2 again turns into 24. And that one actually does get me to 48 there. So kind of just trying it out until you figure out that number. So in this case, it's 2, so r is going to be 2. All right, next up here, we're needing to write this in sigma notation. So I'm going to need an explicit formula in here that kind of describes this sequence. And so I see that this is geometric. I do see that the pattern here is times 6. And you see that every time it's times 6, so that means r is 6. I also see here that by definition, this needs to be a sub 1, because it says we're starting off with the first term. So I'm going to say that a sub 1 is 6 as well. And so I'm going to say a sub n equals 6 times 6 to the power of n minus 1. So that's going to go here. Next up, what I see is that I need the number up top, so that's how, what term is the last term. I can actually just count this, so that's a sub 2, a sub 3, a sub 4, a sub 5, 6, and 7. So I would just count those out in this case. All right, same idea here. So I would say on this one, I can already tell that we're starting at a sub 1, and so this last one must be a sub 4. So I'll go ahead and put that 4 in. And then I need to figure out what r is. So r is any term divided by the term in front of it. So I'll go ahead and do the first two terms here. In this case, I'm going to multiply by their reciprocal by 5 over 1. And so I get negative 1 over 4 when I reduce that. So that's my r value. And I know a1 is 1/5, so I could just say that this is going to be 1/5 times negative 1/4 to the power of n minus 1, since we're starting with a1. All right, this one's asking us for the infinite sum here, infinite geometric series. So the formula for that one is a1 over 1 minus r, but only if r is between negative 1 and 1. If r is not in between negative 1 and 1, if it's anywhere out here or out there, that's going to be when it does not exist, when your r values are outside of that kind of range from negative 1 to 1. So let me check this one out. So I'm going to say r is any term divided by the term in front of it. And so let me just do that on the calculator. I think it's, what is that going to be? It's like 0.01 or something. I'm just going to make sure. All right, so that comes out to 0.01. And so that r certainly does fit in there. And so I can use my formula here. The infinite sum is the first term divided by 1 minus r, which will be 0.01. So that's 4.5 over 0.99. And I get it's 4.54 repeating, although I don't think it's going to like that answer, so I'm going to change this into a fraction here. And I have the button on my calculator to do that, so it's going to come out to 50 over 11. If you don't have the button on your calculator, what you can do here instead is you can actually move the decimal on the top and bottom over. So I'd have to move it the same, so it'd have to be 450 over 99. And then I would just reduce it from there, so I would divide both of these by 9. And that would give me that 50 over 11. So that's what I'm going to put there for my answer. All right, next up here we have non-infinite sum. So you could just plug these in and add them up. It's not that many numbers, but we did learn the formula today for these finite sums is for geometric, which I can tell because this is exponential, is a1 times 1 minus r to the power of n over 1 minus r. So I can see here a sub 1, I would just plug in the 1 since this isn't like a form we're super comfortable with, so I see it's 3. Obviously r is 3 since that's the base of the exponent, and then n is going to be 10 in this case since that's that top number since we're starting at 1. And so I could say the sum is a1 times 1 minus r to the power of n over 1 minus r. I'm just going to type this in the calculator. I just need extra parentheses for the adding and subtracting in the numerator and denominator. So 3 times 1 minus 3 to the 10th divided by parentheses 1 minus 3. And I get 88572. All right, next up here, number 8. So it says that the yearly depreciation is 55%. Its value at the beginning of the year. The original cost is $20,000. What is its value after 6 years? So it's kind of giving me some information here. First of all, it's the original cost. So I'm going to call this a sub 0 is $20,000. Because that's when we first buy it after no time has passed. And then this one's giving us a hint on r here. However, r is not 55% or 0.55. Since it's depreciation, that's a decrease. So that's as compared to 1. So anytime you see that a percentage as compared to a previous year, you actually have to subtract that from 1. So I'm going to say r is actually 0.45. So because 55% is going away, it's like there's 45% left over. So then I'm going to say a sub n equals 20,000 times 0.45 to the power of n. Since I have my a sub 0 up here, my exponent is just n. So then for 6 years later, I got 20,000 times 0.45 to the power of 6. I type that in my calculator, and it does say round to the nearest cent, so I'm going to say 166.08 is going to be my answer for that one. All right, here they are kind of giving us this complicated formula, and we're just going to use it here. They define what it is up there if you really care about it, but I'm just going to use the formula. So they start off by saying that n equals 5, and I see that this is a sub k. So what that tells me is that these numbers up here are actually k values. I'm going to be plugging this in for k. So what am I going to be plugging in for n? Well, I'm going to be plugging in 5 for n just because it says that. So I'm going to kind of rewrite this formula to say a sub k equals 2 over 5 times 1 minus 2 over 5 to the power of k minus 1. So then when it comes to a sub 1, it's going to be 2 over 5 times 1 minus 2/5 to the power of 0. Because it's the 1 minus 1 that I plugged in there for k. So that's going to make that whole kind of parentheses turn into 1. So that answer is just going to be left with 2/5. So then for a sub 2, same idea, just 2/5 times 1 minus 2 over 5 to the power of 1 now. And I would honestly just type that into a calculator at this point. You could do it by hand, but when we get to the later ones, you're not going to be able to. So I would kind of assume that this is a calculator question. And so this comes out to 0.24, or the fraction equivalent is fine. And so just keep going down that list here and do the same thing for the rest of those a subs. Okay, so then next up here, it asks me to find r and s sub 5. So what I'm going to do here, first to find r, I'm just going to do a2 over a1 since I already know those. And I'm going to do decimal forms on both of those, so 0.24 divided by 0.4, which is 2.5, or which is 2 over 5, that's 0.4, so that's why I'm using that. And this comes out to 0.6 for r. And so that allows me to find the sum of the first 5 terms by using my formula here that we used last one, a1 times 1 minus r to the n over 1 minus r. So that would be a sub 1 is 0.4 times 1 minus 0.6 to the power of 5 over 1 minus 0.6. And then I need my extra parentheses in the numerator and denominator. So you get 0.4, 1 minus 0.6 to the power of 5 divided by 1 minus 0.6. Oh, I got to do parentheses there. And that'll give me 0.92224. All right, and then last step here for question C. This one asks you if the initial value was 475, how much is it depreciated after 2 years? So 2 years is referring to a sub 2 here. So it's saying it depreciated by 24%. But remember what I said on the last question, that if it's actually depreciating, what I'm going to do is I'm going to multiply that initial value by 1 minus 0.24. And so if I do that, kind of take my answer from number 2, from a sub 2, subtract it from 1, and multiply it by the value of this asset, that's going to give you your answer, which for this case is 361,000. All right, next up here it says we got a bacteria with 800 bacteria, and it doubles in size. So it's initially 800, so that's at day 0. So then at day 1, it's going to be 1,600, and then 3,200, and then 6,400. So then our formula for this, I know that r is 2 because it's doubling every time. And then I know that I would use my a sub 0 version, so I could say 800 times 2 to the power of n. If you wanted to use the a sub 1 version, you could say 1,600 times 2 to the power of n minus 1, and that would work as well. All right, next up here we need to find the sum, and this is actually neither arithmetic nor geometric, so I can't use either of those formulas. It's actually quadratic, which doesn't fit into either of those categories. So for this one, I'm just going to have to plug and chug here. So I'm going to have to do all of these first 4 terms. and just add them all up. So here we go. So this is -8, -5, 0, and 7. So if I add all those up, that would be -6. All right, this one again is actually neither arithmetic nor geometric, so I cannot use my sum formulas. I'm just going to have to plug and chug here. And what I notice is there's nowhere to plug in k, so how this sequence would look is the first term is just 145 coming from right here. And then the second term is 145 as well, since there's nowhere to plug in these k values. And I would just do this. That would be a sub 1, this would be a sub 2, and I would just keep doing that until I got to a sub 145, which is the number up top. So all of these are 145. It's like I have 145 of 145. So I would just multiply those together, since that's just the quicker way to add that many up. And that's going to be 21025 for me. All right, next up here looks like we have a recursively defined sequence. And so what it's saying is that we have our first term at 136, and then the next term is 1/2 times the previous term. So when I have a sub 2, that's going to be 1/2 times a sub 1. So it's going to be 1/2 times 136. And that is 68. And so then for a sub 3, that's going to be 1/2 times a sub 2. So 1/2 times 68, which will be 34. So I'll let you guys keep going with that list. All right, next up here, we're switching to an arithmetic sequence, and it is a summation here. So our summation for arithmetic is the n over 2 plus the first number, or sorry, times the first number plus the last number. So I have some of this information. I know that I have 30 numbers here. I know that the first one's 39, but I don't really know the last one. So I need to write my y equals mx plus b here. So I know that the common difference is -5. And I need to figure out what's a sub 0. So if I have 39 here, oops, that's not 39 is a sub 1. And I know that the difference is -5, so that's going to be 34 for a sub 2. That would mean a sub 0 would be 44. So I can say a sub n equals -5n plus 44. And then I can go ahead and, since I want to know the 30th term, since that's going to be the last term, I'll just plug in my 30. So -150 plus 44 is -106. And so that'll go there. So now I can just do 15 times -67. I'll go ahead and use the calculator for that. So it's -1005. All right, next up here, we want to express this in summation notation. I notice that the pattern here is plus 3, plus 3. So since the pattern is constant adding, I know it's arithmetic. And so it's going to be a sub n equals dn plus a sub 0, kind of our mx plus b formula. I know that the common difference there is 3. All right, now I need to figure out a sub 0. I know that this first term is a sub 1 since we're starting with 1 there. So the term in front of that, if I kind of subtracted 3, going the other way, would be -2. So that's my formula, 3n minus 2. Now the last thing I need to know is which term is this last number. It's a sub what? So I don't put 178 up there. What I need to do then is plug in 178 into my formula. And so I need to solve this. So 60 is n, and so that means that is actually the 60th term.